Okay. So the too long didn't read version of this is there's lots of fiber in data centers. Often during a compute refresh, that fiber is reused, so it might be a decade old. As you heard from last talk, there's a lot of optics or a lot of push on new optics that is going to create more stress on the links. And so is there a way that, or is there value in doing remote diagnostics and control through the software layer of the fiber that's in the data plant? So going into that a little deeper, I have no idea why this is flashing, but we'll deal with it. As I said, there's with the hyperscale data centers, there's 100,000 square feet, 1 million square feet. There can be hundreds of thousands of fiber connections in that data center. As I said, typically it's not refreshed when the compute cycle is refreshed, so that fiber can be a decade old. And you can see here is some data from one of the hyperscalers showing that there's kind of this range of lengths in the data center. So you can have these under 500 meter lengths, which might be within a data hall. And you have these 500 to 3 kilometer lengths. And while you have the distance, you really don't know much else about that fiber. And so you have some challenges in the fiber plant. And even during installation, you can have issues. And so this shows a chart from another hyperscaler. During installation, you have 40% of the fiber that's out of spec and needs remediation. And even after remediation, it might be 10% of the fiber that can't be used. As the fiber plant ages, you really don't know what's happened with that. There's poor record keeping. Did people clean the fibers when they put the new connections in? Is there splice joints? And then as I said before, with the new optics to try and get higher bandwidth, going from the 100 to 200 to 400 gig, that'll put stress on the link budgets. And also as you go in between data halls, so you might have what might have been 2 links before, you might have a triple link now as you go from a building to a building on a campus. And so that's again challenging the optics. We heard before some of the link budgets as well as you go to 400, not the 100 kilometer links, but maybe the shorter range links. These longer links within the data halls might create problems, particularly with multipath interference. And again, so that's as we're looking at the fiber that's installed, what can we do about that? And so Telesyn's developed a software-controlled reconfigurable cross-connect. This is a robotic-controlled cross-connect that lets you monitor and change the connections within a data hall, or in one of our other applications, a multi-tenant data center. And so a lot of customers have done is actually put in situ fiber monitoring characterization with that. So we have our robotic switch here. In the top there's space for some diagnostic equipment as well, such as OTDR. Of course, if you're putting equipment in a data center, you want it to be highly reliable. And so when the robot is not in using this switch, it's just a latch connection. It's like a patch panel, static patch panel with 2 FC connectors. And our system has been through NEBS level 3 testing. A little background on what the system is. So as I said, with 1,000 ports, we have 1,000 ports in the system connecting from the back to the front. And so there's fibers in the system running between that. And as it's been reconfigured over time, you might have this picture as you've shown with the fibers going through the system. So it might be after 1,000 reconfigurations in the system. And so as you're doing that, if you make a new connection, you want to make sure that the robot's not going to create a crossing or a knot in the system. So that's our algorithm that really allows the robot to find a path around all the other fibers, so the fibers never touch and never cross back on themselves to make a knot. And so that's protected by about 50 patents, and that's what we call our KBS algorithm. So let me see if this video works. It didn't advance the slide. Interesting. I'm not sure why that didn't happen. So now we're stuck. Well, in the next slide, you would see the robot in action. So let me exit and try and start again. It's actually frozen.
Is that frozen or is it just the signal?
So my computer is working just fine, so it's not making any change up to the screen.
Oh, it's so cool.
Thank you.
Yeah.
It's a little too small a screen to just turn around and show you here.
Come see the poster session.
But you can't see the video on the poster session.
You're not going to have your laptop.
Oh, I will actually, yeah, so I could pull it out. Well, anyway, so what you would see in the system is the robot will go down, pick up the fiber, and move it around the others. Since it is robotic, it takes about 1 minute to 4 minutes to make a reconnection. But once it makes that reconnection, it's low loss and latched. So when the fiber does finish with the connection, it also cleans in between the connection. And so everything maintains that low loss performance, consistent low loss performance throughout. It's also low power draw when the robot's in action, about 500 watts. When it's not being used, it's just a server that's running, so it's about 50 watts. And next slide, you can't see either. But it goes through the use cases. And so you can imagine what the use cases would be, doing a characterization during deployment, during refresh. If you turned off a fiber link, you could do diagnostics as well. I mean, one of the things that's also on the slide was optimization of bandwidth and machine learning clusters. And so that's something that wouldn't be part of the talk, but it's something that we've done with collaboration with MIT and Facebook, actually, or I guess Meta now. Where what you look at with, you saw earlier, one of the talks talked about the number of parameters that are growing over time, and I think it was 20 times increase in parameters over 18 months. And so that creates this need to parallelize the algorithms. With data parallelism, it's not as critical. The bandwidth between GPUs doesn't matter as much, but when you do model parallelism, there's a difference in bandwidth requirements between some of the segmentations of the models. And so our colleague at MIT has demonstrated that that's stable and predictable. So you can then optimize the bandwidth between the different GPUs, and that creates this reduction in time for the machine learning with the machine learning algorithm. They've demonstrated both in theory and in practice a roughly 3x improvement in machine learning training. And so if you have any interest in that, I can send you some papers afterwards. Getting back to the topic of the talk now, you can imagine putting this robotic switch inside your data center. And again, don't use a Dell, I guess. That's the lesson we're learning. You put it inside your data center, and then you could use a robotic to do diagnostics or control of the level. And then as a use case, we've actually, one of our customers have implemented this in their network, and this was a dark and lit fiber network provider called Mox Networks. And so between some of their cages in different data centers, they had a 864 count cable running between data centers. They just spliced that directly into the back of our robotic system. When they turn it on, they ran an OT dark test of all the fibers, and so at the beginning that it was clean. They actually found a couple of splice joints in the fibers that they needed to redo. And then as they turn a fiber over to customers, they can do another OT dark test and monitor. They actually found that they did also had a couple of fibers that were constantly monitored. They found a slow degradation on some of them, half dB over a couple of months, and they went out and found that there's a tree leaning on an aerial cable. And so they could fix that cable, before it called a catastrophic failure for the customer and cut the cable. So that's, again, the value of doing this ongoing monitoring and testing of the fiber network as well. So with that, I think I'm about out of time. I want to end with apologies for the screen, but please come by the poster session afterwards. I can show you that video. Thank you.